Hi, this is Mr. Mac. This is the concept video for some special functions. This video really will put the fun back in functions. Now, the three special functions that we want to talk about today are, one, the piecewise defined functions. Two, a type of functions that we ordinarily refer to as step functions. And three, the absolute value function. Okay, we're going to start with the piecewise defined function. So piecewise defined functions. Now, a piecewise defined function is one where we have a function, or we may have a function that's doing something for a while, and then we say, okay, at this particular point, we want to stop doing that, and we want to start doing this instead. Now, notice this is kind of like having two functions. Let's say this is the point 1 there, x equals 1. To the left of 1, the function is doing one thing, and then to the right of 1, it's doing something else. Now, there are a lot of reasons why we might want to do this, but basically, we're looking at a function where it stops doing one thing after a while and starts doing another. Now, ordinarily, the way we write these functions is something like this. We might say f of x is equal to, and then we put a set brace. Now, I'm fond of calling this a mustachioed function because basically, if you look at this set brace in a way, it does look a little bit like a mustache. But anyway, piecewise defined functions, sometimes you'll catch me calling them mustachioed functions. Now, what we do then is we give two or more rules, and then we tell you when to use those rules. For example, we might say f of x will be equal to x plus 2 if x is less than 1, and f of x might be equal to negative x plus 2 if x is greater than or equal to 1. Now, let's go ahead and take a look at the graph of the function that I've written over here. And let's just go ahead and grab a piece of graph paper here. Now, if you were given this function to graph, you would say, I will use x plus 2 whenever x is less than 1. Now, here's 1 on the x-axis. So the line y equals x plus 2 goes through 2 on the y-axis, and it goes up to the right, down to the left with a slope of 1. Now, we can't use x plus 2 past x is equal to 1. Now, here's where x is equal to 1. So we can't use this part right here of the graph. So what we do is we draw the graph, but only over to where x is 1. Now, when x is 1, we're not going to be using this rule because the rule only works when x is less than 1. And so what we ordinarily do is we put an open circle on this end right here. This would be the first part of this piecewise defined function. Now, the second part says negative x plus 2 if x is greater than or equal to 1. Well, now, negative x plus 2 would be a line, I'm going to use a different color here, a line going through 2 on the y-axis and having a slope of negative 1, in other words, going down 1 to the right. So here is the line y is equal to negative x plus 2. Now, once again, we're going to use that only to the right, to one and to the right. So that would be this part right here. And the rest of this green line, even though it does really exist, we would not use that. So if you look then at this graph, this would be the graph for this piecewise defined function. Now, you can have more than two rules for a piecewise defined function. You could put in a third rule or four rules or however many you want. But still, this is actually the way it works. The rule is given, and then you're told what x's to use to find that. Another rule is given, and what x's can be used to find that. Now, what you have to understand is this is a piecewise defined function. If I were to ask, what is f of 2? You should tell me it is 0, because when you look at the input 2 and you look at the rules, here's 1, x is less than 1. See, is 2 less than 1? No, so you would not use this rule. Is 2 greater than or equal to 1? Yes, it is, so this is the rule you would use. So f of 2 would be negative 2 plus 2, or 0. Now, a lot of times what students will do is they will tell me it is either 0 or 4. What they'll do is they'll put 2 in both of these. But 2, 0, 2, 4 is not a function, and we're calling this a piecewise defined function. So when you're given an input, there is only one output that you can give. If you give more than one output, then you do not understand piecewise defined functions. Now, there are lots of problems, odd-numbered problems that are solved, and I would just challenge you to be sure that you watch each one of those, because that will be it'll be necessary to really understand these. This is probably the first time you've seen these.